Alright, welcome to our other video on Java programming language. Today we're going to be talking about data types. Um, Data types, and I'm just going to say, vary across all programming languages, but is pretty much the most essential aspect of all programming languages, in which a data type essentially tells you or tells the compiler or interpreter, which the compiler is deep within a, within a computer. It pretty much is the thing that pretty much puts together the information that you're trying to have the computer, either store or do whatever operation on it, or the interpreter, which essentially the computer takes that information and makes sense of what that information is trying to be or what it's trying to do. Now, data types essentially serve as a way of encompassing the size or, say, scale or magnitude of what is possible to do with that information. And there's multiple varieties of data types, and all programming languages, of course, handle data types in a similar manner, in a similar fashion. But of course, there's different rules. Now, because we're talking about Java, Java has its own way of handling data types. Now, in the previous section, we dealt with outputting information, which we know what a string is, we know what an int is, floats, characters, booleans. We also briefly kind of covered, but of course there's further expansion that we're going to be doing here and how they're handled. Now, there's two categories: primitive data types and non-primitive data types. And we're going to be focusing on primitive data types, which primitive data types specify size and type of a variable value and has no additional methods involved. There's about 8 of these data types. We have bytes, which is 1 byte in size. It stores numbers from -128 to 127. Shorts, which is 2 bytes in size, stores whole numbers from -1 or 32,768 to 32,767. We have ints, are 4 bytes in size. We have longs, are 8 bytes in size. Floats are 4 bytes, which it stores fractional numbers, or, say, as I said, floating point numbers, which see up here, that's pi, first 3 letters, or say decimals. It can store up to 6 to 7 decimal digits, or, say, doubles, which is sufficient for 15 decimal digits. Of course, we have booleans, which they're not the size of a byte, but a bit, which booleans are very interesting in themselves. And when if I ever get into, like, say, digital electronics and do a series of videos on those, booleans are the most fundamental data type of all electronics, or digital electronics, or even computer science. And of course, cars or characters, which is 2 bytes, which can store a single character or letter, or ASCII values, which ASCII values really, it's an older kind of concept. It's not really used anymore. It's now UTF-8. It's been that way since the 2007, 2008 UTF-8, but we're not talking about that. We're talking about data types in Java. But these are some examples of some data types. Now, data types, of course, are handled different. Now, important to know data types because proper data types and using proper data types is important for robust running of applications. Now, of course, we're not running on, of course, low intensity processors anymore. We're not dealing with things in terms of megahertz. We're dealing with things in gigahertz, which, clocking speeds and scope and scale of memory is insane, right? In embedded systems, data types is very, very, very critical and can make or break something regarding, the scale of a project that we're doing in Java. It's a good concept to know, but maybe not the most critical, but it's still important. And we're going to get into an example or some examples. Say a byte example. That's our variable. Say 100 byte example. Sorry about my dog. She will not shut up. So we got our output. That's our byte. Now, if you want to store a value in between those ranges, that does save memory. Shorts as well. Say short example. Say that's in between that, and I apologize for that mistake. Short example. I'll print that back out because that's within the range. Yeah, that's within the range. We already have an integer. But again, that's the range of values possible that can store longs. Say you want to have a number bigger than this huge number. That's where longs come into play. And that's not a non-primitive data type anyway. Say long example. I'll remove those comments. Say, oops. And we put our little L at the end there. Long example. And see, the thing is, if you use improper data types, that is where bugs are created and there are problems that are created. So it's always good to keep within the scope or range. But say, because that number is much smaller than this huge number, they'll print out properly. But yeah, I don't want to do that because I'll mess something up. Now, of course, I didn't put because, again, this is a float, but a double can have twice as many values. So actually, what we're going to do is values of pi. So that's a float, that's a double. This goes up to 6 to 7 decimals, and this goes up to 15 decimals, which that's what it can store. And I spelled decimals wrong. Which, outputting it, it'll print that out, but I'm not going to print every single one. Of course, though, you can print out scientific number as well, which we can. What I mean by that is float example 2 is pretty much a power of 10, which that's what E signifies, is a power of 10. So you can print that out, say, float example 2. That can also be done with doubles, but we're just going to do the float example for just floats. That just moves that many decimal points up. Yeah, that's pretty good for scientific notation. Booleans are fun. Of course, we have my bool being true, or my bool 2 being false. There's 2 possible values a bool can contain, no more, no less. And you know what? When we get into comparators, that we'll work with booleans more. But just think of a boolean right now as a true or false statement. Of course, with characters, you can print out a single character, or say, if you know ASCII, which if say ASCII value, say this will display a character, ASCII value, which that's the ASCII value for 64, say 65 on the ASCII, and of course, you can reference the table. That would be A, say 69, that would be, I think, D or E. Yep, E. We already dealt with strings. But, characters can be represented different ways. Now, non-primitive data types. Now, a non-primitive data type is known as a reference type. And these, reference type. And I spelled reference right there. And they refer to objects. Now these are not predefined. Non-primitives call methods to perform certain operations. These are kind of known as strings, arrays, classes, inferences, and we'll cover all these kind of concepts more in depth later. Non-primitive data types, but primitive data types always have a value. Meanwhile, non-primitive data types can contain a null value, and we'll cover that more later. But yeah, that's our set of videos on data types. Hopefully that was informative. Next one we'll get into casting and operations and other things. Farewell.